Since the announcement of Theodore Maiman in 1960 about the developing of the first laser from a ruby crystal, several laser systems were developed and used successfully in many areas, from industrial to medical applications.
O Centro de Lasers e Aplicações ele está estruturado em duas divisões: a divisão de materiais e desenvolvimento de lasers e a divisão de aplicações. A divisão de materiais, nós partimos da fabricação dos materiais laser ativos e fazemos também a caracterização desses materiais, não apenas cristais, mas também matrizes vítreas, por exemplo. Na parte de desenvolvimento de lasers, nós temos laboratórios dedicados à pesquisa de desenvolvimento de lasers de diodo e também lasers de altíssima potência. Em relação às aplicações, nós temos aplicações na área de saúde, na medicina e odontologia, aplicações na área ambiental, para monitoramento ambiental, aplicações industriais, corte, usinagem, microusinagem e processamento de materiais e aplicações também na área nuclear.
The setting up of the Center Laser Applications at IPEN began in 1975 with the creation of the research group in physics of point defects in crystals. The research led to the Crystal Growth Laboratory for preparing the materials to be studied.
A origem deste grupo de lasers, né, que se tornou o Centro de Lasers e Aplicações de IPEN, remonta aos idos de 1975, quando um grupo que desenvolvia materiais dosimétricos para medidas de radiação, para a confecção de dosímetros, se deslocou para cá com a finalidade de criarmos crescimentos de cristais e desenvolvermos lasers. O nosso grupo fazia pesquisas em defeitos pontuais em sólidos, então nós conhecíamos tudo sobre defeitos, comportamento de defeitos, e os cristais a lasers são baseados nesses estudos.
A crystal is a periodic arrangement of atoms, and the nature produces nature crystals in ordered structures. The development of the processes to reproduce in controlled conditions occurring in nature is the main focus of the research in the Crystal Growth Laboratory. The laboratory has a long tradition in preparing fluoride materials, being the only one in the country with the technology of synthesis, purification, and fluoride laser-active crystal growth. Phase diagrams of crystal growth are investigated from the melt and synthesis processing of nanomaterials. The laboratory has the technology to prepare the crystals of high optical quality and large dimensions for producing laser rods, micro and nanocrystals for use in compact lasers. This technology is also applied in the development of scintillator crystals. In the laboratory of material luminescence spectroscopy, the luminescence properties of active laser materials such as crystals or rare earth doped glasses. Initially, the emission spectra are measured and also the lifetime of luminescent states. A detailed study of the spectra allows the determination of the energy transfer rate between the ions and the absorption cross-section from the excited state. The dependence of the laser emission gain as a function of pumping intensity is obtained from numerical simulation using the experimental parameters. This research method allows the understanding of luminescence processes of solids and their use to the development of solid-state lasers at CLA. The Laser Development Laboratory at CLA develops a series of prototypes. For most applications, a laser should be compact, very efficient, and emit a high-quality laser beam. For this purpose, the laboratory developed its own patent laser technology. This technology uses semiconductor diode as pumping sources, which are extremely efficient and are able to convert more than 50% of the electric energy absorbed by the laser crystal. The lasers produced here emit high power from a few watts until hundreds of watts and operate in the visible from the blue until medium infrared in 2.8 micrometers. In this laboratory, high-power ultra-short laser pulses are generated and used with pulse length between 25 and 100 femtoseconds, where 1 femtosecond corresponds to 1/millionth of a billionth of a second. These ultra-short pulses produce huge intensities, which are enough to cut almost any material without burning it. At the laboratory, the laser is used for cutting and machining metals, plastics, and transparent materials with micrometric precision without temperature increase. Biological tissues are processed, producing results not obtained for any other traditional technique. The ultra-short laser pulses, when focalized on gases, generate light from the visible region until the X-ray, allowing the study of materials at extremely short timescales.
O grupo de lasers começou a consolidar a tecnologia de lasers e buscar várias aplicações. A evolução de lasers, novos sistemas, continuou com o desenvolvimento de um sistema único no país, que é o laser de altíssima intensidade, que atingiu uma potência de pico de 1 terawatt, sendo o laser de maior potência pico no hemisfério sul. O laser de alta intensidade prepara o grupo e a infraestrutura necessária para o Brasil poder acompanhar os desafios da fusão a laser para o confinamento inicial. Portanto, esse grupo está preparado para poder enfrentar os desafios deste futuro.
At the Material Processing Laboratory, high-precision cutting processes are developed. Microdrilling, welding, and thermal treatment with countless technologies already established, such as union of titanium for implants, the welding of thin sections for nuclear fuel elements, and dissimilar material welding for aerospace industry. Using ultra-short laser pulses, structures with dimensions of 1 micrometer are also produced in any kind of material. These structures are used in the microfluidic system production that uses very small quantities of material and optimizes several chemical and biochemical processes. This video shows a water flux dyed in different colors that passes through the same channel without being mixed, confirming the peculiar properties of microfluidics. At the Laser Applications in Nuclear Sciences Laboratory, researches related to the cleaning and decontamination by lasers are in development. At the radioisotopes impregnated surfaces, this technique allows the reuse or recycling exposed equipments to radioactive elements, such as detectors, shields, and treatment of radioactive waste. The laboratory also works in the radioisotopes identification using lasers-induced breakdown spectroscopy, or LIBS. This technique does not need any sample preparation and can be performed at large distance. It has been an important ally in several situations in which the traditional radiation detectors face limitations. LIDAR is the acronym for Light Detection and Ranging. LIDAR systems basically consist of a laser, a telescope, and resembles to a conventional radar. This system detects the presence of particles and gases in the atmosphere up to an altitude of 20 kilometers and can be used for meteorological applications, climatic ones, and for pollution control. The LIDAR system at IPEN is operating since 2001 and has assisted in the understanding of atmospheric phenomena and providing additional data for weather forecasting and air quality monitoring. Using the LIDAR allows to detect the height and thickness of pollution over the city in real time, and the data are accessible via network. Another phenomenon that has been detected and that can affect São Paulo climate is the material transport from biomass burning activities, which happen in other remote Brazilian regions. The Laboratory of Biophotonics has as the main focus to develop new diagnostic and therapeutic methods in medicine and dentistry based in photonic techniques. The laser used are erbium, diode, neodymium, and also femtosecond laser in ablation processes, fusion, or tissue regeneration. As for example, a clinical caries prevention method using neodymium laser was developed and tested in children and teenagers, resulting in 68% of prevention. The laboratory also conducts the study of spectroscopic properties of biological tissues, which is an important tool in diagnostic medicine for several precancerous diseases and tumors. It may even determine its different staging. Also in medicine, the photodynamic therapy of tumors is studied, which after light irradiation promotes cellular localized death. Promising clinical results in animals have been observed and originated a patented pharmaceutics. The Center for Lasers and Applications for MyPen also studies the use of laser in the diagnosis of vascular diseases. Small blood vessels with diameter between 1/10 of a millimeter up to 10,000ths of a millimeter from the microcirculatory system, where there are several vital processes in our health. When a laser shines into the skin, the image captured by a camera is computer processed and generates an image of the microvascular blood flow, allowing a fast and precise diagnosis without any discomfort for the patient. This laboratory is dedicated to the optical tomography development for imaging of scattering media and biological tissues. Several OCT systems with special characteristics are developed here. As for example, this one sensitized polarization that allows measuring the birefringence of non-isotropic materials. This other system can detect changes in liquid flows, such as blood flow. This is the blood flow of a mouse. Different colors represent different flow velocities. In this system, it is possible to capture high-definition images as is observed in the image of a hand palm, which is being performed in real time. The research line of this laboratory is based on the light use as a therapeutic modality in inflammatory process of analgesics, as well as in wound healing acceleration. When light is associated with a photosensitizer, its effect in the treatment of localized infections is studied as, for example, the leishmaniasis. Nanotechnology is also present as an important tool of the laboratory. It is possible to monitor in real-time biological processes through fluorescent nanoparticles that presently are being used in the marking of fungal cells and silver nanoparticles for the improvement of antimicrobial photodynamic effect.
Todos os pesquisadores doutores do Centro estão vinculados a programas de pós-graduação. Programa este vinculado também à Universidade de São Paulo.
The Center for Lasers and Applications is always up to date with scientific and technological development, as well as innovation, by actively participating in international congresses. It is in constant search for new laser applications in the area of basic sciences, providing high-quality knowledge and seeking interactions with companies, promoting innovation and technological transfer.